So the first type of word problem we did in this section was distance, rate, and time. And then we added to what we already knew about distance, rate, and time, wind resistance or current resistance. So this first question says a plane traveled 560 miles each way to Casablanca and back. The trip there was with the wind, took 4 hours. The trip back was into the wind and took 5 hours. Find the speed of the plane in still air and speed of the wind. So you want to set up a variable for your two things you're trying to find here. So we have plane. You can use P, you can use X, it doesn't matter. You have wind. All right, as long as you know and I know what your variables are for. All right, and then you're going to set up your equation. The trip there was with the wind. So is the wind helping or hurting? With the wind, it's helping. So we are going to add those two. So my time times my rate is going to equal my distance, which is 560. On the way back, it was against the wind or into the wind, so it was hurting it, so we're going to subtract those. And those are my two equations. And here's where you want to go ahead and divide. Divide out that 4, divide out that 5. So divide both of these here. So we're going to get P plus W. That's going to equal what? Right. And then we're going to divide this guy out. P minus W is going to equal what? Right. All right. And then it's actually set up for us to go ahead and add, right? We don't have to do anything to this one. We can just add straight down. All right. So we're going to add these just like we did on your quiz, which you're going to get back today, by the way. So your P plus your P is 2P. Your W's will cancel out. 140 and 112 gives us 252. My final step to solve for my speed of my plane is to do what? Right, so I'm going to divide both sides by 2. And when I do that, I'm going to see that my plane will equal 126 miles per hour. That is the speed of my plane. I'm not done yet. I need to find the speed of the wind. It asks for both. So I can go back to either one of these equations. And I can say, well, 126 plus my wind equals 140. So if I want to solve for what the wind equals, I'm just going to subtract that 126 from both sides. And I will get that my wind speed is 14 miles per hour. And now I am done with this problem. I have the plane and the wind. This is the State Fair is a popular trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled one van and one bus with 36 students. High School B rented and filled 13 vans and one bus with 216 students. Every van had the same number of students in it as did the buses. How many students can the van carry? How many students can the bus carry? So again, we have two variables here. We have a van and we have a bus. This is basically the number of students each one of those can hold, right? We have two high schools. We have High School A. They did one van, right? And one bus. And in all of those vehicles there, those two vehicles, they had 36 students. And then we have High School B. They had 13 vans. And they had one bus. But they had 216 students. So I now have two equations, just like I've been solving for this entire chapter, all right? Now this one is not automatically set up for me. It's almost, right? Almost set up for me. I have a B and a B, but they're both positive. So if I add those, one's not going to eliminate. So I need to, what, Jaden? Right, so I need to negate it. So, and I'm always going to negate the smaller ones, okay? Just so I don't have weird negatives to deal with. So in this case, I would actually negate the top one. I'm going to negate this. And remember, if you negate it, you have to negate everything in that equation. If it's positive and you change it to negative, it's negative, change it to positive. Negate the entire equation. Now you can add down. I have a -1 and a 13. That's just 13 minus 1. So I have 12v. Now I have a positive and a -1. That is going to cancel. And then I have a -36 and a positive 216. That's just subtracting. 216 minus 36. Right? And now I have an easy thing I just need to solve. Divide both sides by that 12. All right? And when I do that, I am going to get 15. So I had 15 people can fit in a van. 15 people can fit in each van. They want to know how many people can also fit in the bus. Remember, I had one van and one bus is 36 kids. So I'm just going to plug that 15 in. If I fit 15 of those kids in the van, how many were left to fit in the bus? Well, I'm just going to solve it. There were 21 kids left that would have to fit in the bus. So the bus holds 21 kids. So the van holds 15 students. The bus holds 21. So this first set of graphing is in slope-intercept form, meaning it's ready to graph right away, all right? You always, always, always start on your y-axis, okay? So you're getting your quizzes back today, and on your graphing on these quizzes, some of y'all started on the x-axis, okay? Always start on your y-axis, always. So I'm going to look at this first one. I'm going to start at 8, positive 8 on my y-axis. So I'm going to go all the way up to 8 here and start there. My slope is 2. Remember, if your slope is a whole number, then that's just 2 over 1. Also remember, which there's barely room on this graph, but positive 2 over positive 1 is the same thing as negative 2 over negative 1 when you're graphing, okay? Meaning, if I wanted to graph this, I could go up, that's positive, up to right 1, that's right there. Or I could go down to left 1. You can see those are all on the same line. It's a positive slope. So what you're looking for is my line going up from left to right? All right. And so I have this line. Now, with these, that's a little different than regular graphing. I have to decide if I'm going to make this a solid line or a dashed line. The way I decide that is I'm going to look right here. If it is just a greater than or a less than, I'm going to dash it. If it is an or equal to, I'm going to make it solid. So this is just a less than, so I am going to make this dashed right here. All right. And then the last thing I need to decide is where to shade. So my y value is smaller than this line I just drew. So I'm going to look, my y value is right here. Where is it smaller? Well, it starts getting smaller here. Yeah, on the bottom, all right? And sometimes when they're sloped like this, it's easy, below or above. But sometimes when they're really sharp, it's hard to tell what's below and what's above, right? And so just look at your y and say, okay, here's my positive 8. Where does it go down? Well, 7, 6, 5, 4, 3, 2, this side of the graph. And so that's the side of the graph that I am going to shade. So I'm going to take this and I'm going to shade all the way under this guy right here, all right? And you want to shade lightly or you want to use colored pencils so that you can see the difference in the two. And then we are going to go on to our next one. This one we are going to start at -3. Again, we are starting on the y-axis, -3. My slope here is -9. Now this is a negative slope. -9 can be -9 over +1, or it can be +9 over -1. One is definitely easier than the other. Going down 9 is going to take me off this graph, right? And so I don't want to do that. I'm actually going to use the second option. I am going to start here and I'm going to go up 9, but then I'm going to go left 1. All right? I still want it to be a negative slope, so one of those movements have to be negative. So I'm going to go up 9, left 1, and that's going to put me right here. All right, so I have my 2 points. I need to determine, is this one solid or dashed? Okay, so I'm going to say, do I have an or equal to? Yes, I do. I have an or equal to. So I'm going to make this a solid line. Solid line. Now this is one that's really kind of sharp here, and you're going to say, what am I doing, greater than or less than? Well, I'm doing greater than. So I'm going to look, where is this? This is greater than. Where is it going up? It's on this side of the line. So everything on that side of the line is what I'm going to shade. So I'm going to shade everything over here on this side. What you'll see is you create this somewhat of a wedge. I do not include this part here because that is not part of my blue one. And I don't include this part here because that wasn't part of my green. So the only part that is actually my answer is this wedge right here. So all of this over here is my answer. You do not have to go back and erase as long as you are clear about what is your answer. All right, as long as you're clear about what's your answer. You need to be clear that the answer does not include the parts that aren't there. So it doesn't include any of this, even though we used it to figure out what we were doing. It only includes that wedge right there. So I always advise you to take it from standard form to slope intercept form. When it's not as important when you're just graphing the line. It's really important when you graph the shading, because the shading can change, all right? And a lot of times people get confused. I mean, I saw a lot of people graphing in standard form on the quizzes, and they graphed incorrectly. And so just move it over and get it back in slope intercept form. So you have this x minus 4y is less than or equal to 20. You want to move your x's over. Keep that negative 4y there. Keep this less than or equal to. If it crosses over the inequality, it changes signs. So we have a negative x plus 20. And then I need to divide everything by this negative 4. Every single piece of it by negative 4. My y is just a positive y. Because I divided by a negative, I need to flip that inequality. So now this is greater than or equal to. The x is negative 1 over negative 4, which is positive 1 over 4 times x. Positive 20 over negative 4 is negative 5. So now I have it in slope intercept form and I can graph. Just like the other one, I'm going to start at my negative 5 on the y. Positive 1/4 up 1 over 4. Just like I did before, I'm going to decide that this guy is solid because it's or equal to. So I'm going to make this a solid line. And then I'm going to determine where to shade. Because I flipped it, my shading is actually going to be different than it looked like it would be. When I started, it looked like it would be less than, but because I divided by a negative, it's actually greater than. So I'm shading above this line here. Shading above that line. All right, my next one, 5x minus 4y is greater than 4. 5x minus 4y. So I'm going to do the same thing I did with the first one. I'm going to take it and put it in slope intercept form. Move your 5x over. And then divide everything by negative 4. All right. So we have y, again, we divided by a negative, less than. Negative 5 and negative 4, you can't reduce, but you can make them positive. And then 4 divided by negative 4 is negative 1. And I'm going to do the same thing with this. I'm going to start at negative 1. You can go up 5 and over 4 to the right. They're both positive. Or you can go down 5 and over 4 to the left. Both negative. You can see those are both on the same line and it is a positive slope. This guy is dashed, right? He's dashed because he's just less than. So we're going to make this one dashed. And then we're going to shade. Because it is less than, we are going to shade everything below this line. So we're going to say everything below this line. And then you can see where they cross over. You see that we have this wedge right here. This is where they cross. This is actually my answer. Nothing else on this graph is my answer. That is my answer. So on your sheet, you want to make sure you are very clear about what your answer is. All right.